this video, we will learn about time reversal property of continuous time Fourier transform. If a signal x of t has continuous time Fourier transform as x of omega, then by time reversal property, x of minus t will have Ctft as capital X of minus omega. Now we'll see its proof. We know that continuous time Fourier transform of any signal is given by integral minus infinity to infinity x of t into e power minus j omega t dt. Now Fourier transform of x of minus t will be given by integral minus infinity to infinity x of minus t into e power minus j omega t dt. Now on replacing this t by minus t, we have integral minus infinity to infinity x of t into e power j omega t dt. We can write this as integral minus infinity to infinity x of t into e power minus j into minus omega into t dt. And comparing this with the original CTFT equation, we can write it as capital X of minus omega, or simply we can represent it as x of minus t will have CTFT as capital X of minus omega. Now we'll see two examples. First, consider u of minus t. We know that CTFT of u of t is pi into del of omega plus 1 by j omega, and we also know time reversal property. On combining these both, we can directly write Fourier transform of u of minus t as pi into del of omega plus 1 by j omega at omega is equal to minus omega, which will be pi into del of minus omega plus 1 by j into minus omega. As del of minus omega is equal to del of omega, we will finally get Fourier transform of u of minus t as pi into del of omega minus 1 by j omega. Now we will observe its phase and magnitude spectrums. First, this is the magnitude and phase spectrum of CTFT of unit step signal. Look that at omega is equal to 0, it is having almost infinity magnitude, and for every other omega, it is having magnitude 0. This is because it is a DC signal and no frequency will be there except 0 frequency. And for every value of omega, it is having a phase of minus pi by 2. This is the magnitude and phase spectrum of u of minus t. Its magnitude spectrum is similar to that of the u of t signal. But look here that for every value of omega, its phase spectrum has a value of pi by 2 radians. Now we will take another example, which is signum of t. Signum of t magnitude spectrum also has a infinity magnitude at omega is equal to 0, and it is 0 for all other values of omega. And its phase spectrum has a magnitude of minus pi by 2 for every value of omega. Now we'll observe the phase spectrum of time reversal signum function. Its magnitude function is again similar to that of signum function, whereas its phase spectrum has a pi by 2 value for every value of omega. From these both spectrums, we derive two conclusions. That is, first one is magnitude spectrum is not getting affected when we time reverse the signal, and second one, which is important one, is phase spectrum of original signal and time reversal signal are symmetrical with respect to x-axis, or we can say that an additional phase of 180 degrees is there. Hence, whenever we time reverse the signal, magnitude spectrum will not get affected, but we observe a change in phase spectrum, which is either a 180 degrees phase shift is added, or we can say that phase spectrum of original and time inverter signal are symmetric with respect to x-axis. So these are the references I used for this video.